So, thank you so much, Hassan, for joining us and for giving us your time today. I'm Mani Siddiqui, graduate of Computer Science Department, University of Karachi. So this alumni network was started to kind of help the students and alumni in their career, in their job search, in their education, and so on and so forth. And these webinars are one of those areas that we have been trying to arrange. And Hassan, again, experts like you definitely play a big role in sharing your knowledge, expertise with the students and to really guide them. You know. So thank you so much for doing that. So topic for today is words to wonders and introduction to LLM with Chat GPT and other tools out there. The entire world is kind of buzzing these words. They are curious. What are these technologies? How can we develop those, and what are the use cases? So today we have Hassan with us. Hassan is a consummate professional. I personally know him, have met with him many times. And and if I were to introduce you guys, I have not seen many people as inquisitive, as involved as Hassan. He's like into everything. He also teaches. He also develops code. He has launched startups. He has done, like he has touched everything. So Hassan, the stage is yours. Please take it from here. Introduce yourself and walk us through what you have to share today.
Okay, great. Thank you very much. So my screen is, I assume, visible, right?
Right, it is.
Okay, great. Let me also try to see if I can put it in. Yeah. Yeah, so thank you for that introduction. I don't know what else to add to that, but yeah, basically, I'm a developer based out of Virginia. And that's the best way I can kind of just introduce myself as a developer. If I won the lottery today and I did not have anything to do, I would probably still be sitting and coding something. So not much to add there. As far as the topic of LLMs, large language models, um, so the talk today, we have it divided into like these roughly six parts. I wasn't sure at what level to go into as far as technical depth is concerned, because I'm not sure like if the audience is an expert in this or kind of high level. They have a high level understanding, just as users of Chat GPT. So what I've tried to do is kind of build um, an introduction where I'm introducing. I think somebody is unmuted. So getting some status. Uh, Homer, welcome to the call. If you could please mute. Thank you. Yes, so as far as the talk today is concerned, we're going to go over a brief intro of large language models, then, look at some of the limitations of them, because as powerful as they are, we still have to be wary of some things when using them. Quick look at the open source ecosystem that has developed around this technology. And then I've got a couple of demos. And quick note, we may not get time at the end for Q&A. I'll still try to kind of pace it so that we do. But I do have a hard stop at 1 p.m. our time. So with that, let's get started. And also, please feel free to unmute and ask a question, or I have the chat open on my second monitor. If you want, feel free to just throw in a question there as well. Also in the chat, I have shared the GitHub repo link. So you will find the code that I'm going to show today on there later on today. I haven't posted any code there yet, but I'll be cleaning it up and posting it there. All right, so with that, without wasting any more time, let's get started. If you're completely new to the term LLM or large language model, and you're wondering what this guy is talking about, I'm sure you have heard of Chat GPT. So Chat GPT is just one of the implementations of a large language model. And at a very high level, if I have to describe what a large language model is, you can think of it as a neural network, which is basically a prediction machine. So given some words, it will try to predict what the next upcoming word is. And just from that simple functionality, we are getting so many amazing use cases, and so many other abilities are emerging that these neural networks are developing just when we train them to solve this task of predicting the next word. So the example I have here is like, if I give it the terms, what's the next? This is like the starting text, or what's becoming famous as the prompt. So this is what we prompt the model as, and it'll have a bunch of words it'll try to come up with and assign a prediction to each one of them. Like, given this prompt, what is the most likely thing that should go next? And maybe it says, hey, 91% chance that the next token or word should be word and question mark. So this is essentially all it is when you think about it at a very high level. But going back a few years, where my interest kind of developed in this area is back in 2014 or so. I came across this example. There is this neural network known as word2vec, which is a very simple neural network in relative terms when we compare them to the large language models that we are seeing today. It's just a two-layer neural network, and all it does is you feed it some text, and it takes each word in that text and converts that English word into a vector of numerical values. And it does it in such a way that the relationships between those words is kind of embedded into the model. And then when we do that, we see that we can do some algebraic math on those words then. So for example, if I give it the vector for the word king, and I subtract the vector for the word man and add the vector for the word woman, it gives me back a vector which resembles very closely the vector that it has like 10 years ago. Is that just by training these neural networks on simple language, they're not just mindlessly predicting the next word or just converting them into numbers and doing some mindless computation on them, but when you train it in such a way, it starts to develop a model internally of what those words actually mean and how they relate to each other. So you kind of start to get a sense of like, okay, this thing might actually be intelligent. Now, jumping forward all the way to 2017, I've missed some steps in the middle. We had, a lot of other developments from word2vec until transformers. But they were all, kind of not sufficient to kind of see the science fiction type applications that we are seeing today. So in 2017, some researchers at Google published a paper called "Attention is All You Need." So I would highly recommend reading this, or if you don't have time to read the whole thing, you can just ask ChatGPT to summarize it for you and just kind of get the gist of it. But basically, they introduced an architecture for natural language processing, which takes into account the whole algorithms like word2vec. It wouldn't consider, hey, is the word king being used in the context of like medieval England, or just mentioning somebody as being very rich, like living like a king. So transformers, they actually take a very deep look at the context in which the word is being used. And for whatever reason, due to maybe Google being a large bureaucracy or something, this algorithm that they developed was not paid too much attention to. So it did not gain too much traction inside Google, who was more focused on another type of neural network at that time, which is recurrent neural networks. So they eventually, ended up leaving Google and developing their own thing. And then the very next year, in 2018, a company called OpenAI, which I'm sure all of us are familiar with now, released the first model of GPT, which again is an acronym that pretty much anyone would know what GPT is if you ask them, like a common person on the street. But very few people would actually know what it stands for. And it actually stands for Generative Pre-trained Transformer. So transformer suggesting that it is actually the transformer architecture that was introduced by those researchers at Google. It's generative because it generates, given a prompt, it generates some new text. and it's pre-trained. So once you have trained it, and we'll come to that part, you can kind of start asking it questions like this, giving it some prompts, and getting some output back, which is the step known as inference. So to kind of really understand what's going on inside of these transformers, a really great project that you can look at is a project known as Nano GPT. So I've left the link for this here. It's a project by Andre Karpathy, who was the director of AI at Tesla. I believe nowadays he is at OpenAI. And this is a very kind of simplistic view of what's going on inside of a large model like ChatGPT. It's kind of so small that you can run it on your everyday use machine. And the basic purpose of this Nano GPT is to learn how GPT architecture actually works. So a good example that I found of Nano GPT being used is this article by New York Times, GPT from scratch. So I have linked that over here as well. And what New York Times did was they took all the works of the author Jane Austen, which is about 800,000 words, and they trained an instance of Nano GPT for less than an hour on a simple M1 MacBook Pro. And it had, for reference, 10.5 million parameters. Parameters being the weights that are attached to these neural networks. And general rule of thumb, the more number of parameters you have, the more powerful the model is, because it can build a more fine-tuned understanding of what is going on inside of that text. So then I have some screenshots here from their article. What they find is, before you even start training, right, you give this Nano GPT some prompt. So the prompt is, you must decide for yourself, said Elizabeth. So something that, very similar to what you would find in a Jane Austen novel. And at this point, no training has been done yet on their model. And it just spits out some gibberish. So just some random characters which don't make any sense. After just 250 rounds of training, which, in terms of time, a few minutes, you can see that the model has already developed some understanding of what the text should actually look like. So it has started putting in some spaces. Some of those special characters which are not present commonly in the English language are gone. It has developed some also understanding of punctuation. Junaid, if you would please mute, thank you. So yeah, so it has developed some understanding of punctuation, how that would look like, but still the words, they don't really look like English. Maybe some of them do, but that might be coincidence. After 500 rounds, we start seeing some English words starting to appear. So the, not, and sentences are kind of starting to look more like English sentences. After 5,000 rounds, we see most of the words are valid English words, but maybe the text as it is being used would not make much sense. If it was, a Jane Austen novel, it doesn't make really sense what is being said. And after 30,000 rounds, which is where they stopped, a little less than an hour of training, 30,000 rounds, you can see that it has started to write something which resembles very.
Hassan, you're mute.
Oh no, I don't know how that happened. Have I been audible so far?
Yes.
Okay. All right. Yeah. So I was saying, like, after 30,000 rounds.
You're mute again.
Yeah, it keeps telling me that you have been muted. I'm not sure why.
No, I don't know why. That's weird.
Okay, let's see. All right. Looks like I'm not getting muted again. Okay. Yeah, so after 30,000 rounds, we start to see that, even though it's a very small version of our transformer model, just trained on, 80,000 words, it has started to give us something that looks like very valid English, and not just very valid English, but something that makes sense in the context in which it was trained. So now, just for reference, if I go back, imagine that the Chat GPT that we use on a daily basis nowadays, it is trained on trillions of words, so pretty much the whole internet. It has been trained not just for 1 hour, but many months using hundreds of NVIDIA 100 GPUs, which are massive, massive computation power. And then it has 175 billion parameters. So that kind of gives you an idea of how much more powerful that thing is that we are kind of using on a daily basis, and we are lucky that we have that kind of model to interact with for free on a daily basis. All right, so having said that, what we get out of training like this. So let's say you start with a basic Nano GPT, or if you have access to bigger hardware, a bigger model, you scrape some data from the internet, or you just grab the whole Wikipedia, and you have some GPUs. You start training this model. What you will get at the end of this cycle of training, which is called pre-training, is something called the base model. So base model is trained on high quantity data, but it's low quality data. So nobody has sit down and looked through this data to see what makes sense, what doesn't make sense. We just scrape trillions of words and just throw it at the model, and then it does whatever it does. And at the end, we get a trained model. And basically, the output of the training are the weights, the number of parameters that we have attached to it. They each get some numerical value. And those weights are basically what tell the model, when we are starting to use it, what words to output. And then these base models, if you were to use OpenAI's base models, these are known by names such as Text DaVinci 3. So this is the base model behind ChatGPT. Then there are low-powered ones such as Text Ada, Text Babbage. They are cheaper, but they have less parameters. They have been trained on lesser text. So depending on your use case, you may opt for those low-quality base models as well. And then if you are, as a company, if you're trying to develop an LLM, it's very unlikely that you would do this step yourself, because so far only Google, Meta, maybe some big Chinese companies, Alibaba. I don't know if Microsoft is doing anything on its own, or they're just using the ones developed by OpenAI. So because it takes, this is in the range of $1 million to $10 million you need to train something similar to a Text DaVinci 3, which is the base model for ChatGPT. So if you are a company, maybe you are more interested in this next step, where you take one of the base models that has been deployed by these other companies, and then you fine-tune it. Fine-tuning it is different from the pre-training step, because it is high-quality data. So in most cases, you have a bunch of army of contractors typing in the prompts and the expected response that the model should give as a response to those prompts. And then you just take a pre-trained base model and just run several iterations on it. And then at the end of it, you get a fine-tuned model, which will give you the answers much more, exactly how as you would want them. Because the base model is trained on the whole internet. It has a lot of entropy. It doesn't know what kind of response you're looking for. So one good example I found of this was Khan Academy. They were trying to use ChatGPT's model on their website to build a tutor for children, which could help them with math. But they found that the base model did not have very good mathematical abilities, which, even if you think about it, it's just amazing to think about that this neural network was not trained to do math at all. It was just given the text information, and it has somehow developed this ability to do math. So what Khan Academy did was, I think their chatbot is called Khan Moji or something. So they took that base model from OpenAI, they fine-tuned it on their own high-quality data, and then in the end, now the model that you can see on their website is one which can do 99% of the time it'll give you correct mathematical answers. And then their students can use this model to have that bot act as a tutor, which can walk them through math step by step and tell them what might be going wrong, or what they are doing right. If you want to go even one step further to further improve the quality of your models beyond fine-tuning, there is an intermediate step which is known as reward modeling. So this reward model is built by also taking human curated data. But what is done here is, you give the model some prompt, your fine-tuned model, you give it some prompt, and you output a few different responses. So you run the same prompt multiple times, you get 2-3 different responses, and then you run it past your human contractors who give it some rating, like this is the best one, this is the second best, third best, and then the model is trained on actually ranking the outputs that the fine-tuned model is giving. So the reward model is not going to generate some text for you. It is going to just learn which response is good and which is not good. And then what we can use this reward model for is, you may have heard the acronym RLHF. So this RLHF stands for reinforcement learning on human feedback. And then this is an actual usable model that we get out of the reward model. So we take a fine-tuned model, we give it some prompt, it generates an output, then the reward model ranks that response. It tells, hey, this is good or not good. Based on that, that fine-tuned model gets further fine-tuned. And then at the very end, we get this model, which we call an RLHF model. And then what we find is that currently the state-of-the-art models that we have nowadays, ChatGPT, Claude by Anthropic, Bard by Google, these are all RLHF models. So this is kind of the jump that we make from GPT, which is just our base model, to ChatGPT. So interesting fact about GPT 3.5 API, it has been available since I think early last year, or even before that, maybe in 2021. It was available as an API to anybody who had an OpenAI account. But this thing did not really take off until November of last year. So this whole interest and hype that has developed in this area started in November of last year. And that is when OpenAI, they took the GPT base model and released the RLHF model, which is based on top of it, with which we can have conversations. So what they discovered was, with their API, that even though it was trained to just, given a prompt, generate the next text that should be there, what a lot of people, they were using the API in such a way, because humans converse in a question answer format. So people were saying, hey, imagine, pretend you are this like expert in language translation, and I'm going to ask you this question. So this is the question, take this text, translate it into German or Urdu or something, and then now give me the answer. So even though it was not trained that way, people were kind of using that API in a conversational manner. So that's what, OpenAI people thought, okay, why don't we just build this model to, by default out of the box, just work in a conversational manner. So that's what gave birth to ChatGPT. And I mean, it's really, an interesting point away from LLMs. If you're trying to sell a product, or, your company is, this is, how much packaging matters. Like this API was available for many, many months before ChatGPT was there, but just by packaging it differently, enabling that human conversation, we basically changed the human computer interaction model around it, and then it just suddenly exploded, and everyone is, it became the fastest app to 1 million users, even though the actual technology was always there. And yeah, finally, the point that I have in the introduction is the emergent behavior that we are getting out of this. This is really what has me interested in this stuff the most. Even though these language models are being trained to just predict the next word, what we are finding out is that in the process of doing so, just to develop the ability to guess the next word, somehow these language models are developing these emergent abilities, which were really not predicted. There's an interesting interview of Sundar Pichai at 60 Minutes program. You can search it on YouTube, in which he also talks about this, where they did not really train one of their models to train, I think it was Bengali language. But after they trained it, they found out that it could certainly do that. And there are other emergent abilities, such as reasoning, planning, logic, math. These are all things that were not it was not trained to do, but it has somehow developed the abilities to do. And then, that's where a lot of interest is coming in as well. What if we keep these models, keep making these bigger and bigger? What other abilities are going to emerge out of this stuff? Quick note about, prompting. Some of the terms that you may have heard of or not. Zero shot it means you just ask the model something without giving it any examples. Few shot means you show it a few examples that given this input, this is the output. You give it a few examples, then ask it. In general, we find that this improves the performance a little bit. Another thing which I have found really useful is called chain of thought. So by just adding, let's think step by step, or just adding to your prompt, let's think about it rationally, or let's make a plan to do this and then do this. By just adding these prompts, somehow the improvement jumps up by a lot. We don't know why that happens. There are some good guesses out there, but I'll let you search those on your own. But yeah, if you're just prompting for something, maybe try adding let's think step by step, adding a few examples as well. That'll give you better outputs. Another really interesting thing is flattery. So it's kind of funny. If you're just asking it something like translate this language to that language, or do this mathematics, find the 100th prime number, something like that, it may give you a correct response. It may give you a response that you're not satisfied with. If you just flatter it a little bit, so you say, hey, as an expert award-winning language translator, or as a Nobel Prize-winning mathematician, answer this question, we find that the performance jumps up a lot. And kind of a theory that I've heard around this is that when we are prompting the model, it has kind of thousands of possible words that it could respond back to you with, or even like hundreds of thousands. But when you kind of flatter it, you are telling it that, okay, I need to prune out all of the bad responses. Now, out of this tree of responses that I have, only consider the ones that are associated with a Nobel Prize winning mathematician. So your kind of performance gets better because of that.
So Hassan, really what we are saying is that if we want more meaningful output, we should give more context, more parameters for it to analyze, and then tailor its output according to those, right? So if I don't use the word Nobel mathematician, the model is just going to pick whatever words it thinks will answer that question. But if I use that word like as a Nobel whatever, right, it's going to tailor the response and use those really academic words perhaps, right?
Exactly. Yeah, not just how it responds with like academic words, but also the actual response that it gives you is correct in more instances than not.
I see. Okay.
Yeah. And yeah, you're exactly right. So this is all what we are putting in the prompt itself. Yeah, and it actually, this is the best way I have found of like instead of fine tuning a model or something, this is where, prompt engineers are suddenly becoming so important, because the way you prompt it really kind of affects the quality of responses that you get out of it. Yeah, another thing you can do is reflection. So you can say, hey, answer this thing, and then also tell me, did you do well or not? So sometimes, what may happen in these models is that they can kind of get unlucky. So they are trying to answer your question, but they just pick a word to answer with which maybe it's not possible to answer you correctly. But then it is smart enough that when it kind of thinks about it at a, later after completing the answer, it can say, yeah, but I think, I did not answer you correctly, but I apologize. I think I made a mistake there. So then you kind of know, okay, I have to reprompt and ask this again because it did not do a good job. And yes, and consistency is another way to kind of improve your performance when prompting. So just, maybe just prompt like 5 or 6 times with the same prompt. And generally, the correct response kind of wins out. Like if you're trying to get it to add 2 numbers, the good responses are there more times than the bad ones. So it doesn't get unlucky too many times. So at least kind of prompt, if it's an important thing that you're asking it, at least prompt like twice. All right, so also kind of keeping a eye on the time. I'm going to jump on to the next section, which is limitations. So one thing to kind of understand about these language models is that it is not their job to answer us correctly. What we have trained them to do is, given this prompt, just give me back some text response. And they may very well just make up stuff. There is nothing we have trained them for which tells them that what you answer with must be correct factual information. So kind of a funny and interesting story a month ago or so that I saw in the news. A couple of lawyers went to the court and they presented, some reference cases that they had found similar to their cases. And when the judge looked up those cases, they did not exist. And it turns out that they just asked ChatGPT, it hallucinated, it just made up some cases which looked very similar. So the good thing is, that the good and bad thing is that when you ask it, it will make up stuff that looks very, very similar to actual stuff that may exist. So it's very hard to kind of distinguish between this. So I was also doing some research for, buying some birthday presents, and I asked it, okay, on Amazon, I want to buy for this age kid a birthday gift. Tell me, make some good suggestions. It suggested some really good toys, really interesting ones, but they did. When I looked up on Amazon, they don't actually exist. So something to keep in mind, they have a tendency to hallucinate. So whatever application you are building, you may want to build a layer in there to kind of verify and cross-check that is this stuff actually true or not. It is a black box. So when we train it, we kind of have good idea of what might be going on in there. But even people who kind of came up with this transformer architecture, they'll tell you they cannot tell you with 100% certainty what is going on inside of it. And then that also kind of gives rise to the worries that if we don't know what's going on inside of it, can we possibly control it? If we train it on a large amount of data, is it going to develop some abilities which are not desirable and we don't know why they are there, and suddenly it starts launching nukes or something because we don't actually know what is going on inside of them. They are biased, so because it is trained on data scrapped from the internet, which is by nature biased, so you may get responses especially out of uncensored models which are racist in nature, or biased against some group, and that's just because it was trained on data which is by nature biased. So something to keep in mind as well. OpenAI and Google are doing some pretty good work of curbing down on this behavior by putting in guardrails. So many times if you ask it, hey, tell me how to make a bomb or something, it is not going to tell you how to do that. It'll say, I'm not allowed to do that. As a side effect of that, we are finding that actually the performance of the model is also going down, even on legitimate queries. There are some theories of why that is happening or how to mitigate that. But for now, if you want the best performing model, the best way is to go with the uncensored one. But then, of course, you're opening yourself up to the risk where you launch something to the customers where they can just get any kind of undesirable responses back from the model. Cost, of course, is a big downside. So as I told you earlier, it's expensive to train these. You need a large amount of very powerful hardware. It can take many months to train, especially a base model. So, and then open source community is kind of trying to mitigate all of that, and I'll talk about that in a minute. The context window, that is the best way to get the best response out, but that context window size is limited. So it on OpenAI models, most of them, it is limited to 4,000 tokens, where one token is equal to 0.75 words. So 1,000 tokens is like around 750 words. Some other models, such as I think OpenAI has released a ChatGPT 4 model with a 32,000 token window. Anthropic has a model called Claude, which has a 100,000 token window. So there are models that are starting to come out with larger windows, but for most of the ones that are available now and which are in the affordable limits, it is still kind of limited. And then safety, of course, you have to build those guardrails. Otherwise, these are models that can code. So it's possible that in the wrong hands, somebody could, we could, end up in a disaster situation. All right, we have about 15 minutes left, so I'm just going to kind of speed through this stuff. A lot of interest has, developed in the open source area as well for these models since November of last year, kind of more quickly than we were thinking it would happen. And it mostly kind of sparked out of Meta's model, which is known as Llama, getting leaked. So Meta released this model called Llama mainly for researchers, but one of the researchers took it and put it on BitTorrent, where it just leaked out into the open source community. Everybody has had access to it. So this is the first kind of model outside of OpenAI, which open source community has access to, which has really good performance. So a large kind of community, open source community has developed around it, especially on a website called Hugging Face. So I'd highly recommend you visit this and see what's available there. I actually have a link at the end of these slides as well, and I'll quickly show it here as well. Hugging Face has this chatbot arena leaderboard where they are showing you the current models, which are which are performing the best. So GPT-4 is at top. Then we have Claude, GPT 3.5. Vicuna is something that is based on the Llama model. So it is a fine-tuned version of that model. MPT is something developed by a company called Mosaic. And then at the very end here, you can see most of these are proprietary or non-commercial. And then way down, we can see this Raven is the first one that is open source available for everyday use. Couple of interesting terms in the open source community. You may hear the term quantization a lot, and this basically means so you have 16-bit 16-bit word embeddings representing each word in the model. So you can kind of what open source researchers have found, you can kind of sacrifice on that a little bit, change that from 16-bit to 8-bit. So you're kind of losing out on some of the fine-grained details that the model may have built in there, but it makes it possible to run that model on a smaller amount of RAM. So kind of rule of thumb, you take the billions of parameters that the model is trained on. For example, if it's a 40 billion parameter model, you just double that, and that's how many GBs of GPU RAM you need to run it. So 40 billion parameter model, you need 80 GB of RAM to run it. But if you do quantization, 8-bit quantization, now you can run it on 40 GB. And if you do even further 4-bit quantization, now you can run it on 20 GB of GPU. Another thing that has come up is known as LoRa. So this is a way of fine-tuning these base models where you lock most of the weights within the model, but you build a layer on top of it, which you can train. And this kind of cuts down the training time from months to a few hours. An interesting kind of statement that came out of Google a few months ago, that they don't have a moat. This is kind of still being decided right now. Is open source going to take over, or are these large companies going to keep on dominating this area? It's still, time will tell. We can't really make any judgment on that right now. And just a few weeks ago, Facebook officially released Llama 2, and then this is their actual open source model. This is not something that has been leaked out. So you can legally use this to build commercial applications if you want, and their terms and conditions allow for that. All right, with that, with about 15 minutes left, I'm going to jump into our first demo. This is known as something called file chat. And I've built this because there is a lot of interest among people that, hey, we can query bots like ChatGPT for just data that was available on the internet, and it does not have information after 2021, or it does not have information about my company's private records, or just documents that I have in my Gmail or in Google Docs. Can I build a bot which is trained on those documents and then can answer questions about queries that are most relevant to my data. So for this, I am using a framework known as Llama Index. A lot of these frameworks have kind of just come up very recently within the past few months. Llama Index is something that is really kind of trying to get into the niche of getting multiple data sources and trying to connect them very easily to some of these large language models. So using Llama Index, you can take your MongoDB, just some PDF documents, your Slack chats, maybe your Confluence pages or PowerPoints, and then connect them all together, build an index that the Llama Index can search over, and then hand it over to your large language model. And the place where the need for this is coming out is because, as I was discussing earlier, the context window is limited. You cannot just put all of your documents on Confluence or in your Google Drive. We cannot throw all of them in the context of our prompt and then ask the model to answer that. So that context window is very limited. So basically what Llama Index does is it builds an index over all the data that you have. When you ask a question, first it will do a semantic search over all of the documents that you have. It will find the relevant pieces of information, and then it will pass on your question, your actual prompt with the correct context to the model, and then you get a response back from the model. So that's what I've used here. I'll share this code, like I said earlier, on my GitHub, just installing some dependencies. This function is basically just reading my OpenAI key, which I have created right here. So if you are using this code, just go to OpenAI, create a API key, and just throw it in this file right here. So that's where it can read it from. Enabling some internal logging. Then I have got a folder called documents right here. And then in this document, I just picked up some random files from the internet. One of these is the Constitution of Pakistan. So this is a PDF file. Another one is a CSV file I found, which is just some members of National Assembly of Pakistan, some information about them. I think this is a few years old. And then some, from Kaggle.com, I found this crime statistics of Pakistan over a few years in different provinces. So what I did was then load these documents from that folder and then build an index over them. The way this index is being built is that OpenAI has an embeddings API. So you send them some text, because these models, they don't understand or work with raw text. They convert everything into numerical vectors. So this part here is sending all those files over to OpenAI, getting those vectors back and storing them locally. To save time, I have stored them already into this folder called storage. So if I go one level up into storage, you can see this vector store. This is basically what it converted all those files to. So just raw vectors of numbers. And now I'm telling it, don't build a new index, just use the stored index that you already have. So this is much more faster and also saves me money by not having to make those calls again to OpenAI. Then we are going to go ahead and build a query engine on top of that. And that's pretty much it. We can start asking some questions to our database, which will now be answered in the context of those 3 documents that I just showed you. So for example, and then feel free to, if you want to ask some question, feel free to list it out or just unmute and let me know. So I asked it, list some National Assembly members who have an MBBS. So I'm going to ask this question. And when I do that, it finds the relevant information in that CSV file. I did not have to tell it which file to look into. And then it tells me that, Dr. Haider Ali Khan. And then these responses are kind of different every time I ask it. So this is not incorrect, but there are more than 1 members of National Assembly who have an MBBS. And yeah, so this time it lists out some more. I can ask it some other questions. For example, who can dissolve the assemblies, right? So this is something that it would find in the Constitution PDF. And it can tell me the president can dissolve the National Assembly and so on. So it finds that information from in there. And what's the murder trend in Islamabad over the years, analyze the numbers, make a prediction how this number will change with time. So here we are asking it to do some logic and analysis as well, not just looking up raw information. So now Llama Index tells it that, okay, this information is found in the crime CSV, and then it responds with the number of murders in Islamabad has been steadily increasing over the years. So this is not something that's mentioned in the CSV. It kind of reads the numbers and deduces that. So in 2012, this many murders, and 2015, this many. So this trend suggests that a number of murders in Islamabad will continue to increase in the future. So we hope that's not the case. But as you can see, you can kind of use it as a data analyst. So you just throw a bunch of documents at it. You don't have to search through them and do the analysis. It can do that for you. Part 2 of this same demo, I threw some data into MongoDB here. These are e-commerce orders that happened in Pakistan in the year 2016, 17, and 18. I have the full database here, but I shrank it down because it was taking a long time to run the search over all of them. There are many hundreds of thousands. So I shrank them down to $100 just for this demo. So this is another thing that Llama Index can do for you. I'm making that connection to MongoDB here, telling it which collection to look at, and then what fields within that collection to focus on, status of the order, when it was created, payment method that was used, and so on. I'm going to run that, and then build a query engine on top of that. And now basically I can start asking it questions about those data, which it has no summarization or anything over those things. It's just individual orders, but I can ask it which month are most orders made in. And it tells me that's the month of August. Similarly, I can ask it, which payment method is associated with the most canceled orders. So it can, kind of run that MongoDB query itself, and it tells me, okay, Bank Alphala is the one, at least for those 100 orders that it is looking at. And then maybe which category name has the most returns. So health and sports. So maybe, we don't want to sell products in this category. Yeah, so kind of, quick demo about searching over your personal data. Just kind of scratching the surface here, but I would highly recommend, exploring Llama Index. And you can just imagine the power if you have all the data that you have available to yourself, just connecting all of that to it, all your Gmail, emails over the years, or everything that you have in your Google Drive, and all your contacts and everything. It can do some pretty amazing stuff. Next demo that I'm going to show you is called Jarvis. So inspired obviously from the Iron Man AI. General purpose bot that can just do reasoning and do some work for us. So this is kind of the cutting edge of this stuff. It doesn't work exactly as you would expect it, not something you want to use in production, but I still wanted to include it because this is where things are headed, where we are going from just a large language model to artificial general intelligence, which can do general lookup, reasoning, logic for us. So it can plan, reason, observe what results it got back, and then act based on those. For this, I'm using something called LangChain. So LangChain also is a very interesting framework. It has some overlap with Llama Index, but Llama Index is more focused on just getting all your data, building indexes over it. LangChain can do some of that, not as well as Llama Index can, but it has some concepts which you can think of it right now as kind of duct tape, which holds all these different concepts that are evolving very quickly together. For example, prompts, models. So you don't want to rewrite your code for different models, right? When you're evaluating them for your company, you can write that all of that prompts and everything for LangChain, and then these LangChain folks are doing the work for you, where you just tell it, okay, instead of this model, now start calling Google's model or Anthropic's model, and then the same prompts kind of work over there. You can build data connections. They have that concept of chains, on which obviously their name is. You can chain together these different components to build complicated applications. And then the most interesting thing that I really like is, they also have the concept of memory. So because your general conversation with these LLMs is very transactional, especially when you're using the API. They don't have memory of what happened before. So LangChain can hold that memory for you. And then the most interesting thing is agents, where agents are, you can think of them as AI personalities, which you can task them with doing specific things. And then you can also chain all of these together. So there are different agent types. For example, you can add human as an agent. So when a question comes up that the LLM thinks, okay, the best way for me to get this answer to this question is the human, it will just prompt you to provide that information. Search could be one of the agents. They have a mathematical tool, so that could be an agent. And so let me show you this, because we're kind of very running close on time there. This is the second demo called Jarvis. Again, importing in that OpenAI key, building that, getting a reference to the OpenAI model. And then here I'm just asking it a general purpose question just outside of the Jarvis demo. Yeah, that's exactly what happens with me every time I do a demo. Let's try this again. Okay, it worked that time. So I asked the model what would be a good company name for a company that makes colorful socks, and it says Bright Socks. Now I'm gonna import in some LangChain chat models, some file IO stuff. And this is basically where I'm building the chain for my agent. So here I'm providing it reference to an agent which can do searches. So I have a basic search engine deployed on my local at this port. And then this agent is going to be able to do search and use the calculator. So let's run that. And now just to show that it can do searches, I can search for large language model on Wikipedia. And when I run that, it should give me back the Wikipedia article for that. Now I'm going to build the agent. And so now I have an agent which has the ability to do search and to do some basic math. So let's ask it some stuff. So I'm going to ask it, based on the weather tomorrow, should I visit Lahore or Karachi? And now OpenAI, it does not have real-time information, right? So the first thing that this agent is going to do is it's going to make a plan of how to answer this. So it says retrieve the weather forecast for tomorrow for both Lahore and Karachi. Then in the next step, compare the weather conditions for both cities, including temperature, precipitation, all that. Analyze the weather conditions and consider personal preferences and activities planned. Determine which city has more favorable weather conditions, and given the above steps, respond to the user's original. So this is, I find this really amazing that this language model now has this ability to plan that this is how it can best answer this question. And now for each step, it can determine from the tools that it has available, which are search and math, which one is the best suited. So its first step is weather forecast for tomorrow, Lahore. So it's doing a search on that. So it did an internet search. It got a response for that. Then it gets the weather forecast for Lahore and Karachi and so on. So it does its thing. And let's see if it is already complete or not. And this is where I was telling you, it's kind of cutting edge. It'll fail sometimes. Let me go ahead and run it again. So the error that it was giving me right there was that it ran out of the context window, which is just 4,000 tokens. But basically, yeah.
I would like to be cognizant of a time you have to leave at 1.
Yeah.
Is that right? Okay.
That's right.
It's almost 1 o'clock.
Yeah. Yeah, I'm going to jump off. Let's just quickly see if this. Yeah, so it's giving us, based on the weather forecast tomorrow, Lahore is expected to have thunderstorms, and Karachi, on the other hand, is expected to have overcast weather. So, and then it is still going on. So let's see if it made a final recommendation.
We probably lost you.
Oh, can you hear me?
Yes.
Okay, sorry. Yeah, I was saying I'll share this code up there. Unfortunately, we are out of time, so you guys can play with it yourself. But yeah, thank you all. I have to, unfortunately, quickly jump to another meeting. Thanks.
Thank you so much, Hassan.
Yep, bye.
Thanks for your time. Bye now.